Yo, 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 this is Coach Ray, a.k.a. J Money, here teaching a new lesson. Today we're going to do graphs of radicals. This is going to be a quick, short lesson. Most of it I want to show you on Leftmost. In fact, this is the only screen I need you to look at right now. I'm not going to write anything on here, but this is information that could be useful to you. All right, in my class, all of our graphs in every unit, I allow you to use Leftmost. So I'm more worried about you understanding what you're looking at on a graph than I am focused on you being able to actually put your pencil and mark the correct points and that sort of thing. But here's information that you need to know. Radicals, when you're graphing radicals, they're going to look like this. Sometimes there is a number in front of the radical that we call a. That would vertically stretch or compress by a factor of a. It also reflects it across the x-axis. Just like parabolas, by the way. Okay, so if we have an A, that makes it wider or narrower. Same thing. You'll see that when we get to Leftmost in a second. And also it can flip it, which means reflect it across the x-axis. All right, so that's if there's an A. If there's an H, meaning if there's something underneath the house or underneath the radical with x, it says that it's going to translate the function right and left. And it does so in the opposite direction of the sign in front of h. That's because the formula says x minus h, kind of like the opposite of h. So if I have x minus 5 underneath there, that means my function is actually going to move 5 spaces to the right. Okay? Plus k, if I put something outside of the house in the back and I add it or subtract it, that's going to translate the function up or down. And it does so in the same direction of the sign in front of it. So if it's plus, it moves it up. If it's minus, it moves it down. Okay, let's take a look. I'm going to pull up Leftmost. There it is. Okay, Leftmost, and I'm going to start with y equals square root of x. This is the parent function. We call it the parent function because it's the most basic version of this unit, which is a radical. Okay, so this is what radical graphs look like. Not that interesting. It looks kind of like half of a sideways parabola. All right, let's start by messing with a. If there was a number in front, let's say I make it 2. Ooh, goes up, gets wider. Okay, let's say I make it smaller, 0.5. Oh, makes it smaller. Okay. If I made it negative, what's going to happen?
It's going to
flip to the bottom. Okay, so that's what a does. All right, let's put something underneath the house. Let's do minus 2. Moved it to the right 2 places, yes? Yeah. If I did plus 2, moves it to the left 2 places. Okay? And then finally, if we put something in the back, minus 3, moved it down 3 places, plus 2, moves it up 2 places. So that's what those 3 different numbers, how they affect this graph. Let me show you an example of what you're going to have on your assignment. Okay, in Alex, all right, if you look closely right here, let me make this a little bit bigger. Okay, you have 2 questions on domain. All right, so we've done domain all year long. I expect that you're okay with domain. Okay, and then there's 3 where it says graphing a square root function, and then there's 3 different types of problems. Let's do one. All right, we'll do this one together. So what it'll look like on your end is it'll say graph this function, and then to do so, graph the leftmost point and 3 additional points. Then click the graph icon. So you're going to actually see the graph. You're going to have your little tools like the pencil and everything. You're going to plot your 3 points, and then you're going to hit graph, and it'll graph it for you. All right, here's what I would do. If I was given Leftmost on this, I would plug in that equation, square root of x plus 3 and then plus 2. Okay, so square root of x plus 3, x plus 3 underneath, and a plus 2. All right, so here's what I'm looking at. It looks like it moved it left 3 and up 2. That makes sense. All right, and what did these directions say again? It said, to do so, graph the leftmost point and 3 additional points. Here's how I would do that. Leftmost point, you can just see it, right? The one that's furthest on the left is right here. If you click it, it should show up. It's not staying there for some reason. Okay. My Leftmost is freaking out. All right, so that point is negative 3, 2. That would be the first point you put on your graph. All right, every other point, we need one that's hitting a corner. We've done this before. I would do x equals, and let's do negative 3, for example. Negative 3. Then you can click on that intersection to see exactly what that point is and make sure it's not a decimal. All right, where's the next place where it looks like it might be right on a corner?
1 and 4.
I'm even thinking maybe right here, -2.
Oh, yeah.
Let's try that. So x equals -2, and let me click and check. Yay. So one of my points could be -2, 3. All right, the next one, you said 1. That looks like that might be 1. Let me click, make sure. Yep, there's a point at 1, 4. All right, let's see. What about at 12? It looks like 12 is close. I can't tell if it's perfect. If I clicked on this one at 12, you get a decimal. So you know that that's not one of them. Okay, but you only need to find 3 additional ones other than this initial -3, 2. Okay, and that's it. That's how I would attack these assignments. Okay, so that's a nice short video. Good luck on your assignments, and I'll catch you in the next video. It's been real. Deuces.